about prototype for a smart home gardening system. We are providing automatic watering and fertilizing solution, store sunlight and rain detection. Then user can monitor through IoT application like temperature, humidity and soil moisture. Lastly, user can control through IoT application which are watering, fertilizing and shading.
For our problem statement, our project needs a way to monitor the condition of the plant such as soil moisture, humidity and temperature. Then people have been very busy and tends to forget to take care of the plant. And also lastly, we need a method to monitor and take care of the plant from far away. For our objective, we want to design and develop a smart home gardening system that will assist the user with their gardening tasks and care and routines. So the first one is to design and develop a system that can detect soil moisture, humidity and temperature. Then, we want to develop an automation that can automate the process of controlling and monitoring. Lastly, we want to develop a remote monitoring system for smart home gardening system based on IoT that is user-friendly.
Now I will present about the hardware that we choose for our system. First, we are using Node MCU ESP32 as our system microcontroller. Next, we are using the DC water pump to pump the water and fertilizer to the plant. And we are controlling the water pump using the 2-channel relay. Next, we have the soil moisture sensor module to detect the soil moisture level. And also water level sensor to detect the water tank and fertilizer tank level. Next is the light sensor module to detect the surrounding light intensity. And we have the DHT22 temperature and humidity sensor that can detect temperature and humidity. And we have the servo motor to open and close our shading. For the software, first we are using the Arduino IDE to write our code into ESP32 microcontroller. Next, we are using an application called Blink, which is an IoT application.
Alright, now I will explain to you about the block diagram of our system. So first of all, we have 3 sections, which is input section, process section and output section. For the input section, we have a soil moisture sensor module, temperature and humidity sensor DHT22, light sensor module and water level sensor. Next, for the process section, we use Node MCU ESP32 microcontroller. And for the output section, we have IoT controlling and monitoring using Blink application, 180-degree servo motor, 2-channel relay module to control DC motor for water and fertilizer. This is the circuit connection of our system.
This is our design consideration for health and safety. The development of this project is to promote the gardening being exposed to plants and green space. Then, equipment in this project are safe because the voltage is safe and suitable for user to use.
For the environmental consideration, our system is eco-friendly that promotes gardening activities within the household. And these gardening activities can help clean the polluted air, reduce carbon dioxide and provide more oxygen. And lastly, this system only requires minimal usage of energy and resources possible.
For cultural and benefit to the society, we consider the 17 SDG. So the 17 SDG, we want to end hunger, achieve food security, improve nutrition and promote sustainable agriculture.
Okay, I will present about water level sensor operation. So this is water, this is fertilizer. When the water below the sensor, it will show notification on the phone and the LED will light up. Same goes fertilizer. When the fertilizer below the sensor, it will show the notification and the LED light up.
Okay, now I will show you how our project detect dark surrounding. Right now, while our surrounding is light, the surrounding dark LED will not light up. But when the surrounding is dark, then the surrounding dark LED will light up.
Now I will demonstrate the humidity and temperature sensing in our system. This is the temperature and humidity reading in Blink application. So the temperature will be in Celsius and the humidity will show as a percentage. Okay, so now I will present to you about the soil moisture detection in our system. So this is the range for the soil condition of dry, average and moist, and then the gauge color are red, yellow and green respectively. So this is the soil moisture gauge. It shows the red color indicator which indicates dry soil. Okay, right now the soil moisture show the yellow color which indicates average moisture. The soil moisture gauge shows the green color which indicates moist soil condition. The soil is moist LED will turn on if the reading below 1200.
Now I will explain about how our system detects strong sunlight. First, we need to check two parameters condition, which is the surrounding is not dark and also the temperature must above 34 degrees Celsius. And if both of these conditions are true, then it will indicate there is strong sunlight. Now the shading is open, and from the Blink application, we can see that the automation is off, but the temperature is above 34 degrees Celsius and the surrounding is not dark. So when the automation is turned on, the shading should be closed, indicating strong sunlight. Now I will explain how our system detects the rain. So for the rain, there are four parameters condition. First is the soil is moist. Second, surrounding is dark, temperature below 28 degrees Celsius, and humidity above 90%. For rain detection, 2 or more out of 4 of this condition met, then it will indicate it is raining. The shading of the system is now open, and from the Blink application, we can see that the automation is off, but 2 or more out of the 4 parameters condition are true. So when the automation is on, the shading should be closed. For our system, it will water the plant twice daily, which is morning 9 AM and evening 7 PM. And for the fertilize operation, the system will fertilize the plant weekly once. The time is Sunday morning, 8 AM.
Alright, now we will show you how the user can manually water and fertilize the plant. Okay, so now I will on the fertilizer pump and then water pump.
Okay, I will demonstrate how the user can manually open and close the shading. So now the shading is open when 0 degree and the shading is closed when 180 degree. So for the conclusion is this project can be connected with IoT, then easy to monitor and control the system even though the user is far away. Lastly, the design model for this project is considering the cost and reliability for the system.